In this video, we will review different types of polygons. So first question is, what are polygons? As the name suggests, poly means many and gons means sides. A shape with many straight sides is called a polygon. Alright, so I have a list of shapes here and I would like to discuss those one by one. So first shape that we have here is, so this one is having three sides and three angles. So we call such shape is called triangle. Similarly, next one we have four sides and four angles. So this will be called a quadrilateral. So quad means four, lateral means sides, quadrilateral. So any shape with four sides is called a quadrilateral. So next one, so please count the number of sides that we have here. So we have 1, 2, 3, 4, 5, 6. So we have 6 sides. So a polygon with 6 sides is called a hexagon. Next we have another polygon. So this one has 1, 2, 3, 4, 5. So this is a closed shape with 5 sides. We call it pentagon. Penta means 5, gon means sides. A shape with 5 sides is called pentagon. And again, this has 5 angles. So next one is a little bit different than what we have already seen. So interesting, but let's see what we have here. So first count the number of sides. So 1, 2, 3, 4. So we have 4 sides here. So you will be surprised to know that this is also a quadrilateral because it has 4 sides. But what is different between this quadrilateral and the one we have seen before is, okay, so let me just highlight it. So I'm talking about this quadrilateral and I'm talking about this quadrilateral. So if we compare these two, so in this one we see that all angles are less than 180 degrees. So all angles are less than 180 degrees. But here you will notice that one of the angles, let's call this alpha. So angle alpha is greater than 180 degrees. So if we have a polygon with an angle whose measure is greater than 180 degrees, so those are called concave polygons. But if we don't have any angle greater than 180 degrees, then we call convex polygons. So all the other three shapes that we have discussed so far, so those are convex polygons. So all others are convex polygons. So I'm just gonna write the concave in front of polygons which have the concavity, which have a greater angle greater than 180 degrees. So let's move on to our next shape. So in next one we have how many sides? 1, 2, 3, 4, 5. 5 sides. So this is called a pentagon again. But if you compare this pentagon with the one we have on the top, so this pentagon and this pentagon. So if you compare these two together, so you will see that the new pentagon is different because this angle, let's call this angle beta. So angle beta is greater than 180 degrees. So it's even more than a straight line. So again, this is our concave polygon. All right, so moving on. In the next one, So if you count the number of sides, so again this is a polygon. So we have 1, 2, 3, 4, 5, 6, and 7. 7 sides. So a polygon with a 7-sided polygon is called a septagon. So this is a 7-sided polygon with 7 sides, 7 angles, and this is called septagon. Similarly, we can count the sides on the next one. So 1, 2, 3, 4, 5, 6, 7, 8. This is called octagon. It has 8 sides and it has 8 angles. So all the 8 angles are less than 180 degrees. So this is also a convex polygon. Alright, so next one we have 1, 2, 3, 4, 5 sides. But if you notice, this one is a pretty looking, it's like a beautiful looking pentagon. So what is special about this pentagon is, so did we do a pentagon before? Yes. So we did a pentagon before, but that one wasn't as pretty as this one. So if we compare this pentagon and this one, so what we notice, so when we do this comparison, we notice that this one is a pretty looking one, because the reason being, so all the 5 sides here are equal, and also all the 5 angles of this pentagon are same. So pentagon, so what properties it has? Same length for all the sides and same angles. So all angles are same. So this one is called regular pentagon. So any polygon which has the same length of all the sides and same angles, so that is called regular pentagon. So another example of a regular polygon would be, so if we can think about, I'm just going to draw a shape here. So this looks like a square, and again in this one we have 1, 2, 3, 4 sides, and all the 4 sides are same. So square, 4 sides are same, 4 angles are same, because every angle is 90 degrees. So this is an example of a regular quadrilateral, because it has 4 sides. So square is an example of regular quadrilateral. Similarly, if you have a triangle with all the 3 same sides, so that is called equilateral triangle. And in an equilateral triangle, we have all the three angles same, all the 3 sides same. So for example, if you have something like this, so in this one, so if I have all the same sides, all the same angles, so this would be called equilateral triangle. So all the angles are equal, all the sides are equal. Okay, same angles and same sides. All right, so let's do one more. So this one, we have 2 sides are equal, and this is a triangle. It has 3 sides, and also we have, so if 2 sides are equal, so these angles gonna be equal. So the angles which are opposite to the equal sides. So angles opposite to the equal sides are equal. So this is called isosceles triangle. So isosceles triangle, and the important property of this triangle is it has two equal sides and two equal angles. And you should be able to know which two angles are equal by just looking at the triangle. So in this case, so this side is, so angle opposite to this side is this angle, and angle opposite to this side is this angle. So the angles opposite to equal sides are equal. Next, we're gonna discuss the areas and perimeters for the quadrilaterals. So we have different kinds of quadrilaterals. So quadrilateral is a shape which has four sides. So let's try to look here. So first we are given that if you have a rectangle, so rectangle is a shape which has opposite sides same. So it says that let B be the base and H be the height of this rectangle. Then area is given by the formula base times height. Similarly, if we want to figure out the perimeter, so perimeter is just essentially the length of the boundary of a shape. So you don't need to memorize the formula for the perimeters. So you can just sum all the sides of a polygon. So it's length of the boundary. So simply add all the sides together. So in this case, we can see that, so we have two B's and two H. So 2B and 2H. So just add them together. Next, we have a square. So as we talked about square, so square is a shape whose all sides are equal, and so if you have a square with a side B, so something like this. So if you have a square with a side B, so all the sides are equal, so area would be given by B square. And for perimeter, we just add B plus B plus B plus B 4 times, and we get 4 times B as our perimeter. So next we have parallelogram. So in case of a parallelogram, so we have the opposite sides parallel. So for example, the opposite sides are parallel, opposite angles are parallel. And if you have one of the bases being B and you have the vertical height, the perpendicular height H for a parallelogram, then the area is given by B times H. And similarly, if you want to figure out the perimeter, so opposite sides are same. So this is A, so this is B. So you have two A's and two B's. So 2A plus 2B will be the perimeter. Next we have rhombus. So in case of a rhombus, so what is a rhombus? So basically rhombus is a parallelogram again, and it has all the four sides same. So let me just redraw it. So we have parallelogram with all four same sides. So angles are same, sides are same. So each side is B, 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 B. And again, so you will have the height and the area would be given by B times H. Next we have trapezoid. So trapezoid is a special quadrilateral. So what is the speciality of trapezoid? So we can So I'm just going to draw a trapezoid. So you have two parallel sides and two non-parallel sides for a trapezoid. And so let's say this is side is A, and you know the length of two parallel sides. So this is B, and the vertical height is H. So in that case, area of trapezoid is given by the formula. Area is equal to half the sum of parallel sides times H. And for perimeter, you simply add all the four sides together. So let's say that the other sides are C and D. All right, so this is the overview of all the formulas for different kinds of quadrilaterals. So now we're going to use these formulas to do some problems. So take a moment to read this example. So we have a sheet of metal. So it is the shape of a parallelogram, and there is a piece that is punched out. So we need to figure out two things here. So first we need to figure out area of the piece that is punched out, and then area of the metal that was left. All right, so we can start finding with area of the piece that got punched out. And one thing we noticed that the piece that was punched out is the shape of a rectangular piece. So the piece that got punched out is a rectangle. And we can figure out the area of that rectangle. So we can figure out this gray shaded area. And we have this rectangle. So 13 inches by 16 inches. So area would be 16 times 13, and we have 208 square inches. So never forget to include the units in your area. Now for part B, so let's do some thinking in order to figure out part B. So we need to figure out the metal that is left. So we need to figure out this red area. So the metal that is left. So in order to figure out this red area, we can figure out the blue area, the area of the whole parallelogram, and we can subtract the area of rectangle that is there in the middle. So our plan is, so in order to find area of metal that is left, so that would be area of, so I'm just going to draw the shape, parallelogram minus area of rectangle. So area of parallelogram. So we know that in this case, the area of parallelogram would be B times H. B times H. So in this case, the base is given to be 42 and the perpendicular height is 19 meters. So we have this for area of parallelogram, and we have the area of rectangle that we have already found in part A. So we have under 8-inch square inches. Alright, so now we're just going to do the subtraction and we can get our desired area. So when we do the calculations, we got 798 minus 208, so which means 590 square inches is the area of the metal that is left. Alright, so let's take a look at the next problem. So take a moment to read it and then we can try it together. So we need to find the perimeter and area of the gray shaded region. So as I said that the perimeter is simply the length of the boundary. So in this case, let's start with our perimeter. So we're gonna simply add the boundary of gray shaded area. So we have, so let's think about what is this length. And we also need to think about what is this length. So the total is 15. So this would be 15 minus how much? So 15 minus 4. So that is 11 because this length is 4. And similarly, if you want to figure out the other one, so this would be 30 because this total length is 30 and then we have this 8. So we can just do 30 minus 8, which would be 22. 22. Right, so now we can figure out our perimeter. We can simply add all the sides together. So perimeter would be 8 plus 15 plus 30 plus 4 plus 22 plus 11. And is also total perimeter is 90 centimeters. All right, let's take a look at one more problem that relates to the areas. So in this one, we have 3 different floor spaces and all of them are trapezoid shaped. And we need to figure out the total area that is covered by the floors. So in order to do that, so we can figure out the area of Dan's tennis shop, area of Bob's fishing emporium, and area for Caroline's golf shop. Recall that we just learned today that area of a trapezoid with parallel sides AB and a vertical height h is given by the formula a plus b over 2 times h. So I'm going to use this formula to figure out the floor area of different shops. So first we're going to talk about Dan's tennis shop. So using the area formula, so sum of the parallel sides, so in that case, we're going to take the sum of this side and this side. So sum of parallel sides, so 275 plus 188 times the height, and height in this case would be, so this would be the h. So this would be 60 divided by 2. And we get the area for Dan's shop, which is 13,890 square feet. Next, we move on to Bob's Fishing Emporium. So for Bob's Fishing Emporium, so if we try to figure out area, so it should be sum of parallel side. So one side we know that is given 108. But what about this side? So what about this side? So this side, I'm going to call this side AB. So from the diagram, you can see that AB is equal to sum of 60 plus 108 plus 75. So 60 plus 108 plus 75, and we got 243 feet. So the other side would be 243. And the height would be, so in order to figure out the height, so we are gonna consider this height. And we know that this whole thing is 275. So this much height would be essentially, so it would be, so I'm going to call it h. So h would be 275 minus 188. So we are doing this whole length minus the tennis shop, the other side of that. So we got 87 feet. So height is 87 feet. And using this, we got the area for Bob's floor is 15,268.5 square feet. Lastly, we're gonna find the area for Caroline's shop. So for that, area would be sum of the parallel sides. So it is given straightforward. So 128 plus 215. So these are the parallel sides. And then the height is 75 divided by 2. So we get 12,862.5 square feet. Since the question is asking us to find the total area, so for total area, we're going to sum all the three areas that we just found. So total area would be 13,890 plus 15,268.5 plus 12,862.5. So total would be 42021 square feet. So you can analyze the problems and then maybe you can split the problem into different parts and figure out the area of parts and then add all the areas together. So depending on the problem, whatever is asked, so always try to do small steps first. So in the next video, I'll discuss the Pythagoras theorem. So make sure you watch the next video as well. Thank you.